Welcome to section 6.6, function operations. This is really about adding and subtracting, multiplying and dividing your functions. And here is the general setup for the notation of function operations. And this here is the notation, sorry, that doesn't look very good, for these functions. And notations here. In other words, this is how it's written, is that you're taking function g and you're adding another function for it, or to it, of x. So this is pronounced f plus g of x. This is pronounced f minus g of x, f times g of x, and f divided by g of x. Now, a lot of people may interpret this right away as, oh, you're multiplying f plus g times x. That is not what we're doing. Absolutely not. This is just the notation. It's saying that you're taking f of x and g of x and adding them together, which is exactly what this is. F of x plus g of x. F of x minus g of x, f of x times g of x, and f of x divided by g of x, provided that g of x is not 0, because we don't like to have 0 in our denominator too often. So let's take a look at how this plays out with some functions here. I'm just going to highlight these real quick. I'm going to be using this function and this function, and we're going to be looking at adding, subtracting, and these two functions together. So let's take a look. We're going to add these two, f plus g of x. In other words, you're going to add f of x plus g of x. And real simply, you're going to take 4x plus 7 plus radical x plus x. 4x plus 7 plus radical x plus x. Combine like terms, 4x and x for 5x, and 7 and radical x. These are all three different terms, and we are all done. That is your solution. Next one, we're going to subtract these functions, and sure enough, f of x minus g of x. So we're going to have f of x plus 7 minus this whole thing. What some common mistakes are is that people fail to distribute this negative to both of these terms. In essence, what you're going to have is 4 minus x for 3x and 7 minus radical x. So you're going to have a negative radical x and a 7. So sometimes people will just go ahead and distribute the negative right away. Here, we've got 4x plus 7 minus radical x minus x, and then combine like terms. 4x and negative x for 3x, 7, and then your negative radical x. Either way, you must take care of those negatives. They are a common tripping stone for some people. I don't want that to be for you guys. So let's scroll on down here for a couple other examples. To finish this up, they had what are their domains? In other words, what are all the values for x that you can plug in to these functions? Take a look here. The domain of f is a set of all real numbers. The domain of g is all the numbers that are greater than or equal to 0. And the reason that the f of x has all real numbers is that you can plug in any number in here to that x, will be totally safe. However, when you look at the g of x function, this has got a radical in it, and you can't plug in any negative numbers in here, or they'll be imaginary numbers. So they have to be 0 or greater than 0, I should say, which is exactly what they have here as their domain. This has to be positive, 0 or higher. This one here, any number will work. You're going to have two different domains for two different functions. Let's take a look at another set here. A little little bit of difficulty here with my computer today. I cannot wait to get a new one. Here we go. So let's take a look at these two functions, f of x and g of x. And again, they want us to add these two together and ask us what are their domains. Well, the first one here, we're going to add addition. So we're going to have 2x squared plus 8 plus this function right here, x minus 3. Combine like terms, and we're going to have 2x squared plus x plus 5. That's all you have to do. They just wanted us to add these functions together, and sure enough, here we are. Now, the nice thing is that let's take a look at our domains. There are no radicals and no denominators, so for this, you can have a domain of x being all real numbers. Sometimes you'll see this as the symbol for all real numbers. Feel free to use that. It's awfully helpful just to go ahead and save some time. Now let's take a look at the subtraction. So we're going to have 2x squared plus 8 minus this thing. If you want to use parentheses, that's fine. Probably be a good idea. Now, this is going to be 2x squared plus 8 minus x minus negative 3, so that's going to become plus, and then you simply combine like terms. Nothing with 2x squared. 8 plus 3 is going to be 11, and you're going to have that negative x right here for a standard form. Let's take a look at the next operations, multiplication and division. And here we have two new functions, f of x and g of x, and they want to find out what it's going to look like when you multiply these two functions together and when you divide these two functions together. The first one here, they're showing you that you're going to multiply the two functions, and sure enough, that's what you're going to do. X minus 9 times x plus 3, and you're going to use the FOIL method, x cubed, 3x squared, negative 9x, and negative 27. Nothing to combine. This is in standard form. For the division, let's take a look. They have x squared minus 9 over x plus 3. However, we realize that x squared minus 9 is a difference of squares. So we're going to factor this out and then do some canceling. By the way, when you cancel, really what is left over is 1. So you're going to have 1 in your denominator. 1 times x minus 3 is x minus 3. Now, take a look at your original right here. You're going to have to find out what x cannot equal. The way to do that is to set your denominator equal to 0. Because having a 0 in the denominator, let's just say for right now it's bad. And we want to avoid that. So x cannot equal 3. So now let's take a look at the domains for both of these situations. The domain for both f and g is a set of real numbers. So the domain of f times g is also the set of real numbers. As you can see right here, all reals for this one, all reals for this one. So the multiplication is going to be all reals. However, when you look at the division of these two functions, it's a set of all real numbers except what we found, x cannot equal. X cannot equal negative 3. Let's take a look at a couple more examples. Let's pull that back. There we go. Let's go ahead and multiply these two together. We're going to have 3x squared minus 11x minus 4 times 3x plus 1. And we're going to have to go ahead and distribute using the FOIL method, 3x times all this. And 1 times all this. And combine like terms. For the division, we're going to have 3x squared minus 11x minus 4 all over 3x plus 1. Now, remember, you can only cancel factors. This would be a good note to take. Only cancel factors. Whoops. Not Keneal, but cancel. Never cancel terms. And remember, terms are separated by pluses or minuses. That's a good little reminder for you. So we've got this nice handy-dandy little problem here, and it's going to get a little bit fuzzier here for us because we're going to have to use our old factoring techniques, our old friend factoring. So let's take a look at how we can factor this. Up top, is there anything we can factor out right away? No, so let's multiply the head times butt, find factors equal to gut. Well, what are factors of negative 12 that add up to negative 11? Well, hopefully we've done enough factoring that we know that factors of negative 12 that add up to negative 11 is going to be negative 12 and 1. So I'm going to have negative 12x, that's not negative, and that's not 12. Negative 12x plus a 1x minus 4, and we're going to factor that by grouping. And we've got happy cows because these little corrals have both the same sign. So now I'm going to factor out what I can here. I'm going to factor out a 3x and factor out a 1 here. And my numerator then is going to be 3x plus 1 times x minus 4 all over 3x plus 1. Now remember, you can treat this entire denominator as one factor. So I can cancel that factor with this one, and remember when you cancel, 1 is really left over. So this is going to simplify to x minus 4 all over 1. Now let's go back and take a look at what our domains are going to be for this. Since our domains for f of x was all reals, because there's no denominators, no square roots, all reals for g of x, therefore the f times g, we're going to have all reals as our domain. However, for the division, we have to set this equal to 0 to see what x cannot equal. So I'm going to subtract 1 and divide by 3. So my domain is all reals except negative 1/3, sorry. We just have a little bit left over in the video. What I'll show you tomorrow in class is the composition of functions, where you're going to have something like f composition of g. I know it looks like the word fog, but this is called composition right here. And we will talk about that more in class, and I will see you then. Thanks.